Good.
Can you hear
Okay,
me?
so it's a great pleasure now to introduce Thomas Lenarz, professor from Hannover Medical School, who's going to give us a talk on the state of the art of implantable hearing devices. So it's over to you now, Thomas.
Okay, thank you. So we have a few slides, and let's go to that. It's well, when we look on hearing loss and the auditory implants we have available, then we probably can say that at the upper end, for profound deafness, the cochlear implant is basically serving the patient. When we go down to the pure conductive loss, then the BAHA bone-anchored hearing aid solutions are available. And in the middle, we have other solutions for patients with either mixed or pure sensory hearing loss. And here, the acoustic implants or middle ear implants come into play. So they can actually serve patients who have moderate to severe sensorineural hearing loss. And in addition, they can have also conductive components. So if we go up in this direction. We want to go through this field briefly. Well, the BAHA, the bone-anchored hearing aids, are basically available in two versions. They are for mainly for conductive loss. We have the percutaneous solution. We have seen already demonstration on that. So the active part is completely out of the skull. It's only the screw that transmits then the sound into the skull and vibrates it. Now, there is also a transcutaneous solution, and Salcha will show it in a minute, that you actually have also the passive part here in the skull. This is a magnet plate, and attached on top of the skin is the counterpart magnet, and the active system with the vibrator is still outside of the skull. So that's a so-called BAHA attract system, which basically avoids the percutaneous screw. Then there is another bone-anchored hearing aid, so to say, the bone bridge. The difference is that the active part, or mainly the vibrator itself, is implanted, which is then under the skin. And the external part, which is worn on the head, is just a speech processor, which takes the sound, transforms it into electrical pulses. They are transmitted through the skin onto the implant. Here's the receiver coil, and then the energy drives the vibrator. So that's basically the transcutaneous active bone-anchored hearing aid. Now, they all are for mainly conductive losses. Now, when we go higher up with the hearing loss in terms of moderate sensory neural component, then active middle ear implants or acoustic implants come into play. Just make a difference in stimulation. Acoustic hearing aids, they stimulate the ear via the sound wave from the outer ear canal. The cochlear implant stimulates directly the nerve with the electrode in the inner ear. And in between, we have the mechanical stimulation. Implantable hearing aids, they couple anywhere at the ossicular chain or also in the inner ear, and they basically deliver vibrations, mechanical vibrations, which are then brought into the inner ear. And these vibrations use the cochlear reserve, which is still there. So the patient needs enough cochlear reserve in order to use this vibratory information. Now, the working horse is a vibrant Soundbridge from Edel. It's, as we can see here, a magnet, permanent magnet, coil around it. The AC drives the magnet forth and back. There are bumpers, and the whole thing is moving like that. In order to transmit it to the ossicular chain, you need some coupling side. You see here the classic one on the long process of the incus for many sensory hearing loss. But there also, you see it intraoperatively, how it's fixed here, very nicely in that condition. Now, there are a lot of other possibilities to couple. For instance, we can go with a torp, we can go together with a porp. We also can go with a piston directly through the footplate, or we can also couple on the round window. And all these versions have been used and are still used, and they work very well depending on the individual patient's situation. Here you see some results from the round window coupling. There's a special coupler made to fit the size of the vibrant Soundbridge floating mesh transducer to the niche in the round window. and here you see how it's placed here. Now here you see a patient audiogram. That is mainly what they have. Mixed hearing loss, that is the bone conduction, that's air conduction on average. And here you see what the patient gets as the gain, the aided threshold, so to say. It's mainly here in this mid-frequency range. And when we look what the patient gets in terms of benefit, such on speech discrimination, there is a huge improvement over the non-aided situation. So these patients really benefit from that implant and the coupling side. Now, if the hearing loss, the sensorineural component is more pronounced, then we need more powerful devices, which actually use 2 points of fixation. And one is in the field that is Otolaryngology, the middle ear transducer, and the fully implantable version called the Carina. Now what they do is actually to use 1 point of fixation at the rim of the mastoid, as you can see it here with this plating system. There is a transducer, and the transducer itself goes then onto the, for instance, incus head or any other place on the ossicular chain, and transmits the sound directly to the chain. So here you see the fully implantable version with, again, the transducer, but also the battery and the microphone. So this is a fully implantable system. It's basically usable in patients who have not that much inner ear hearing loss. Otherwise, you might get feedback if the gain you need is too high. You also can couple it to other sides. Here you see the Stapes head coupling, in this example. So that also works. Now patients get also improvement. We see here the speech performance, that is a monosyllable word test, percent correct. You see non-aided, that is with hearing aid, and that's what they get with this MET. So a huge improvement for those patients who probably don't benefit from conventional hearing aid. Conventional hearing aids might have the difficulty to get the sound across the whole middle ear into the inner ear, and these devices are much closer to the inner ear, which might explain why they do better in those patients. Now the most recent development is the Codax. That is a system where we also have a transducer mounted on the rim of the mastoid. Here we have the transducer with the artificial incus, and here on the incus we put on a Stapes piston. It's also a two-component system and an external speech processor worn behind the ear. Here we see the whole system in the schematic graph. That is how the piston then goes into the inner ear through the footplate. Here an intraoperative situation, as you can see it here, that is through the posterior tympanotomy to the middle ear. A footplate is, so to say, prepared, and then we can place it in place. You also can go anteriorly if you want and do it, but in most cases that's not necessary. Now, what do patients get? Well, that's basically their threshold. There's AC, that is bone conduction, though they have severe to profound mixed hearing loss. And with the surgery, you see there's probably no change, not a much change. A bit of improvement here, the so-called card effect. And when we look on the free field audiometry, that's what the patient has unaided. That's what he gets with his hearing aid, and that's what he gets with the DUX. So you see we have more gain across frequencies compared to the hearing aid, and this already shows that's very efficient in stimulating. So far we have 86 patients implanted. You see different conditions. Half of them have fixed Stapes footplate, for instance, advanced otosclerosis. But we also have mobile Stapes footplate, as you can see here, all types of reasons for or etiology for this mixed hearing loss. What does the patient get? Well, the blue bar is always the situation with hearing aid pre-op. The green bar is what he gets post-op, and that is monosyllable word scoring. You see, astonishing, some patients, they basically have 0 score with a hearing aid, but they jump up to 80–90% with the DUX, and that shows how powerful the direct coupling in the paralymph is. It's highly significant, the improvement they show, and okay, the same is true for 80 decibels down from the, okay. Now, in terms of speech intelligibility, we can also look not only on word recognition scores and preparing pre-op hearing aid versus post-op DUX, and you see most of them really have improvement. We also can look on speech and noise, and here you clearly can see the true benefit they have, because hearing and noise becomes much better with the Codax compared to the hearing aid. Now, you can argue, well, why not doing first Stapes surgery, for instance, advanced otosclerosis, and give a hearing aid? Here you see a subgroup of those patients who had it. What you can see is that we have, for instance, the pre-operative, post-operative bone conduction, there's probably no change with the exception of this one patient. And when we look on the speech recognition, you can see that the work recognition scores are much better with the DAX compared to the previous situation where they had already Stapes surgery and hearing aid. Yeah? So this, you see, that shows really the huge advantage they get with that. Now round window coupling also works. One patient here, you see that's bone conduction threshold pre-post. Then also Stapes head coupling works. You see patient jumps from 45 to 80% monosyllable word scoring. So there are also different possibilities to couple. Not only through the Stapes prosthesis. Now, codax versus cochlear implant. The question is, when do we go from codax to cochlear implant? Well, there is, of course, transition zone. Once the sensory component is more than 70 decibels, basically, then the cochlear implant might be better. If you are below that, then you see that the codax is better in this comparison between two groups of patients who have some overlap in their, as you can see here, some overlap in the indication criteria. But most of the green ones are up here with HSM sentence test in noise compared to the blue ones down here. Now, if it's beyond 70 decibel loss, of course, then the cochlear implant is leading. We have some patients who have on one side the codax, on the other side the cochlear implant, and you see with comparable thresholds, basically they do better with the codax as long as you not exceed the 70-75 decibel hearing loss in the inner ear. Now, indication criteria to summarize, well, vibrant Soundbridge is basically something which is for moderate sensory neural component. In addition, they can have also conductive component. Then we have vibrant Soundbridge coupling is also effective. Then we have CYMOS, that is a MET implant. It has, you see, can serve patients with more pronounced severe hearing loss. And then the Carina is probably the same, a bit less because they have this feedback issue. And then we have the Codax, which basically could serve any kind of hearing loss. But in terms of cochlear reserve, we also would limit and say you see 70, 80 decibels, then above that, the cochlear implant is really the most important thing. Okay. Well, thank you very much for your attention. That's a brief summary on the acoustic implants.
Thank you very much. That was great, and it's really good to see a lot of these things put into action today. So I think now we're going to go over to the operating theatre in Hanover to Rolf.